Hello, anyone there? Anyone there? Testing one, two, three, one, two, three. And sounds a little weird, but it looks like everything's good. Um, Not sure why I did that, but let me go ahead and get things a little bit started here and get this out of the way. So hopefully you're doing well. You're doing, you've enjoyed the week and you made it through, getting closer and closer to Christmas time. Just trying to do a couple things on this side of the screen because some settings didn't stick for the stream. There we go. There we go. All right. All right, how's it going, everyone? And welcome to another Zeal stream. And hopefully you are doing well. Just taking a sip of my tea. Make sure you have hydration. Always important to stay as hydrated as possible. So what are we going to do today? We are going to work on some more Advent of Code challenges. Where we left off last week was we started doing day 1 of the Advent of Code. Off stream, I've tackled at least day 2, and now we're on to day 3 of it. So we're just taking our time. I'm not trying to do the problems all on the same day. It's already up to day 12. So the Advent of Code stuff, it's just flying by. So you can see that's already on day 12, or day 12 is about to release around day 11. I've already solved the second day's problem, and then we're on day 3. So I was getting the repo set up and everything. We're still going to be using code spaces. So that's how I've been. That's how I did day 2 actually. I cracked open. I went on code spaces, and I went on code spaces on my tablet and was tried to do the day 2 problem solving stuff. So that was really cool and really fun to do. And we're just going to keep on going with that. So let's just make sure our font size seems decent. And let's talk about what day 3 looks like. So let's go ahead and open those files for day 3. So day 3 is a little bit of a doozy to start off, and not exactly sure how we're going to tackle this. So let's talk about what day 3 is all about. So I'll just read through the whole thing. So toboggan trajectory. So day 2 had so actually let's talk about day 2 first and what went down on day 2. So day two was the password philosophy. So it was so the premise was that the database, or however they store user passwords, didn't follow the new toboggan company's password validation. So, and the rules to whether a password was valid for the first part of it was, so you got an input like this. The first part of the input before the colon was the rules for if the password is valid. So in this case, I believe a password had to appear between 1 and 3 times. So or a character had to appear 3 times. So A had to appear between 1 and 3 times for a password. So this one, I believe, ended up being valid. B had to appear between 1 and 3 times. So each line gives you a password policy, and the password policy indicates the lowest and highest number of times a given letter must appear for the password to be valid. For example, 1 through 3 means that the password must contain A at least 1 time and at most 3 times. So there you go. Okay, so it's the upper limit. So this password contains A 1 time, B is not even containing here, so that's not valid. And then C can be can appear 2 to 9 times. and this condition passes. So these two passwords are valid. The middle one wasn't. So had to parse the input and come up with the solution. So that input was, let's take a look at the day 2 solution. So that input was such that, so we parse the rows. So we take in the arguments, which is the file. And let's take a look at day 2's input file. So day 2 looked like this with a bunch of those rows for each password policy. I parse that out into individual rows, map over. Right here, we mapping over the rows. And for each row, we check if the password is valid. So I created this validate password. It takes in that row, that input. I split it based off the colons. And then so we have the left and right side. The left side is the policy. The right side is the password. I go through and trim it, get rid of any white spaces and stuff like that, just to make sure everything is good. And then I have this method that checks the condition. So whether the password passes the condition. So we expect a tuple since it was split. It's not a tuple. It's a list. Expect a list with, on the left is the rule, on the right is the password. So I made a method to get the conditions for the rule. So it parses the left side, gets the min and max integer. In this case, the range, and then I converted that to a range. So the range is the number of times a character should appear, and then the character. So that's what that is. And then I ripped up and then I converted the string into individual characters, the graphemes, and then count the occurrences, and then count the number of occurrences of the letter that we're trying to check for. Count that, and then I did a check for if that number was within the range that we figured out it to be, and that would return that returns a true or false. And then at the end of it, after I get that input of an array of true or false, and then count the number of trues. So it's probably not the most optimal, most efficient, but it is, it's Elixir. So we're learning, and this is helping a lot for me practice my Elixir foo. So, and then part 2 of the exercise took in the same input, but the difference is that the letter for the numbers that specify, instead of specifying a range of how many times the letter should appear, it specifies the valid position of that letter. So for the first input, the letter A should appear on the first position or the third position. It has to appear on the first position or third position. If not, it's not valid. So for the first input, A is valid because it appears on the first position, the 0th index. B, for the second one, B needs to appear on the first or third position, and it does not. C and E do. And then for C needs to appear in the second or ninth position. But the gotcha with this one is, I forgot to mention, is that it should only appear exactly once. So it can't appear in both positions. It has to be in either or. So that one, I basically created a brand new flow for checking these conditions. I didn't really piggyback off of the other one. I wasn't sure how to do that. So it's the same password validation flow where we split the left and right sides, and then we do a check condition. And then and then get valid position, I parse the left side with the rule and get the letter and the positions, and then I set the position, and then I get the first position and the second position, which are P1 and P2. I subtract those by 1 because we're dealing with arrays with indexes starting at 0, not index of 1. and then the letter. So we have the first position, we have the second position where it can possibly be valid, and then so it's following the same kind of principle where I split up the characters into the each I split up the string into each individual characters, and then I get I check to see if the character is at for the list. I check to see if the character is at either position, and I pass that. I create a list out of that, and then I check if I check if it appears twice. Like if it appears twice, I check if that letter appears twice, and then if it only appears once, then I say that's true. Um, and that works. That works. So we have our solutions for a D2. All right. Now on to day 3. So and if you happen to be curious and want to take a look at my code, at my my highly engaging code, I will throw a link in the chat if you're curious. And I do not guarantee the quality of my code. We are learning Elixir. But the main point is to do and learn and grow. That's the main thing. Practice, practice, practice. So there it is, the current repo that I'm pushing my solutions to. All right, so now we're on to day 3. So what does day 3 have us? So with the toboggan login problems resolved, you set off toward the airport. While travel by toboggan might be easy, it's certainly not safe. There's very minimal steering and the area is covered in trees. You'll need to see which angles will take you near the fewest trees. Due to the local geology, trees in this area only grow in exact integer coordinates in a grid. To make a map, your puzzle input of open squares is the periods, and trees is the hashes, the pound symbols. You can see, for example, and then here is our layout of our forest, or whatever you want to call it, of our map. These aren't the only trees though. Due to something you read about once involving arboreal genetics and biome stability, the same pattern repeats to the right many times. So this pattern repeats over and over again, creating like this map that repeats to the right. So you start in the bottom on the open square. So you start on the open square period to the top left corner and need to reach the bottom. So we stop on the top left. Okay. And then the toboggan can only follow a few specific slopes. Let's see. Okay. Just checking the front door. So the toboggan can only follow a specific slopes. You opted for a cheaper model that prefers rational numbers. You start by counting all the trees you would encounter for the slope right 3, down 1. So our slope is going to be going right 3, 1, 2, 3, and down 1. From your starting position at the top left, check the position that is right 3 and down 1, then check the position that is right 3 from down 1 from there. So until you get past the bottom of the map. The locations you check in the above example are marked with a 0 where there is an open square and an X where there is a tree. So illustration of going down right 3 1, right 3 1, right 3 1, all the way down. This example, traversing the map using the slope, would cause you to encounter 7 trees. Starting at the top left corner of the map and following the slope to the right, and right 3, down 1, how many trees would you encounter with the puzzle input? So I started off with the example input so we can try to solve this. So the interesting thing about this is that we have to keep on repeating the map over and over again as we reach the boundaries of the current one. And we want to go So we want to go 3 and down 1. So and we can only go 3 and down 1 for our problem anyway. So our x is 3 and our y is 1 going down 1. So now we just have to figure out how we're going to do this. Traversing the map doesn't seem too bad. First we need to convert this map into something we can actually traverse. So we'd probably want to parse this into their individual list items, and then so it would be a list of lists is my thought. So each one of these rows, so it's a list of lists. So it's a two-dimensional. In other words, I think it's the qualified term is two-dimensional array. But in this case, we don't deal with arrays in Elixir. We deal with lists in Elixir. So let's try to see about parsing that information. We already have some code about parsing stuff. So let's try to, so we already have our parse rows. So that'll break things up into the individual rows. So let's go ahead and let's just start with that. So args, let me make sure to launch this in G shell. So now we want to parse rows. And then after parsing rows, need to parse each item in that row, or so there's parse rows and then there's parse row. Not the most descriptive right now, but this will do for now. And then we want to take string graphemes s, and then this will convert this into a list. So now we have a list. So then we want to map over this actually. So this gives us a map, or an enum map, and we want to map over this and parse a row. So then we get this should give us, so this is going to give us tuples with strings with the dots, comma, and then the next one will give us, and this one will give us, converting those to individual dot hash dot, and then dot so I'm keeping an eye out on my phone, by the way, if you see me looking at my phone, because my brother is going to be dropping off his dog soon-ish, because we're going to be dog sitting. Let me comment out part 2 just so it doesn't cause any lint issues. Okay, and then we get that. So we get a list of lists. So now that we have our list of lists, now we want, so this gives us our map area. I guess this gives because this has to repeat over and over again. So I'm wondering about just doing map section. Just calling this a map section. So now we want to get to the point where we're traversing down the way, navigating the map, and then repeating because I'm not sure. I guess we could get the dimension. I guess we could technically know how many times that we need to construct the map. So thinking this through, we know now that we've parsed this out, we know the number of y's. So we know we kind of know the x and y dimensions of this. So given that we know the y, the how many times we have to go down, we can generate the map by figuring out how many times, how many increments down they're going to go. So, or I guess we know how many increments are going to go down. We need to figure out how to generate that to the right, because the y doesn't matter. It's going to the right. So if we know the width of a sector, then we know we just have to do a little bit of math of the width times the width of it times the height, or not the width times the height, but get the area. Not good at math right now. So let's see. So let's just do some regular old pencil math here. So how wide is this thing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 11. Looks like it's 11 characters. Let's do jump check. 1, 2, 3, 4, 5, 6, 7, 8. 10. So it's 11 characters. So the width is 11. And then let's just take a look at what the height is. So the height is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. 4, 5, 6, 7, 8, 9. So it's 11 by 11. Really? Okay. I wonder if it actually says if like the map would be like evenly spaced, like an even square. Your coordinates in a grid. In a grid. Yeah, okay. But yeah, that grids don't guarantee. So how many times did... So this map had to be repeated around 3 times. So if we do let me do some math here. So we have to do it 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay. So do 11 by divided by 3. That should work. Because y times 11, or y times width is, or y times height is 11. 3. Okay. Width times height. Okay. Let's see. Oh. Well, there goes the webcam, so that explains that. I wonder why the webcam is like... The old software seems to be buggy. It's just like turning off. And not sure why. That sucks. Let me see about getting the other webcam up. Because that webcam is being annoying. How about this? No, not that. How about this? There we go. Sorry for the technical interruption as things get weird. So, yep, no clue why. No clue why. Okay, well, we got that going again. So we have our map section. Let's try to see if we can get the width and height from this. So the width, the height of the map is, or of our section is just the enumerator. Is it just count? Let's find out. Elixir. Yeah, count. Yeah, so if we get a tuple and we just do count, it will, of our map section, that will give us our height. If we want our width, we do enum of our, and we want to get our map, we want to get the width of one of the first elements of our map section. So and then at 0. So we just get the first section and get the count of that. And that should give us our width. What's this about? Parse row does not exist and is being expanded to parse row. Please use parentheses to remove any ambiguity. Interesting. Is that gonna help? see what the thing says. I guess if I wrap this in a func, it will not get as angry with the ambiguity. I hope. So if I do this, there we go. Now it's happy with that. And then yes, those aren't used. I know that. And then map section repeat. Hopefully I did my lame math correctly, or so I do. So it was the width multiplied by x divided by height multiplied by y. And then we probably want to try to do a floor on this. And that is just, looks like there's like a kernel floor. If you want to perform floor operation on other decimal places, use float for. Okay, so there's just a straight up floor that we can call. And it's probably going to complain that unused variable. Yeah. What's this complain about? That's a typo. And then map section repeat. So now we want to draw our map. I guess what I could have done theoretically is just took a look at the map section again and just keep on traversing until we reach the end of the map section to make this easier, or potentially make this easier so we don't have to count. It's like once we identified that we reached the boundaries of the width of the map, we just go look at the map section again, the next section of the map. But let's just try this. Let's just go with this idea. And now we can revise this. So now we need to, now I was thinking about adding different lists together and see what happens if that is a thing. So let's take a look at lists. And if it's possible to concat like two lists can be concatenated and subtracted using plus minus. So that would result in that. So what happens if it is a, so 1, 2, 3. What happens if it's a 2-dimensional array is what I wonder. So let's experiment in the terminal real quick. Come on, there we go. So let's do, actually let's take our little dummy code here. So let's close this off. So we have one list. There's our list. And then let's do the exact, and let's concatenate. I think it's plus plus. What? Why isn't it? Okay. It's not letting me do a plus plus. Okay, there we go. I wonder if it's my connection to the server that's lagging out. Okay. So let's see. So I expect period, hashtag period, and then to be in the same. Oh, it isn't in the same. It just okay. So it didn't concatenate the inner one. So it just okay. Just repeated the pattern. Okay. So it's just doing a string concatenation. I was wondering. I was curious to see if these two, since they're at the same index, if those would be concatenated. But I guess that does reflect what's going on here. So let's see. Let's see about duplicating. So you can duplicate a list multiple times like that. I'm just curious to see if there's any other like concatenation type of like stick them together type of dealies. Type of dealies. Last differences, pop, replace to atom. Not much else. So if I were to get one of these, and so the repeat just in the documentation, repeat just repeated, or duplicate just took a character, or just took a tuple and then, or a list, and just duplicated it 3 times. I'm curious to see if I can like find another way to like repeat the list multiple times. Let's take a look at enum to see what type of operations we can do with enum. So chunking, no. Let's see, concat. So that's just concatenating 2 things together. Find filter, find flat, into. Let me check something real quick here. Okay. Find flat frequencies, group, into. What's into do? Inserts an interval into a collectible. Okay. There's our join. Map every max member min, random, or reduce, or reject, scan, shuffle, sort, split, take 2, unzip, with index. I guess what I could do is, if we know how many times the map needs to repeat, what I can do is this. So list duplicate, 3 times. If I can spell duplicate, that would help too. Dupe, not duplicate. Duplicate. So duplicate does that, and then if we pipe that into enum concat, then we get that, and then we get our duplicate thing. So if we wanted to build the map, so now let's build the whole map. So let's take them. So we're taking in the map section. we want to enumerate map over each section. And that will do, so this is a row. And we'll just do this, the thing we just did now, where we take a list, duplicate the row, map, section, repeat, and then pipe that into enum concat, and then end that. And then we have our map. I think that'll give us our map. I'm curious to find out. IO puts map. What's that going to give us? So if I do mix D03 part 1 map section repeat is unused. Okay. Compilation error undefined function part 2/1 on line 11. What's going on? What? On line D03 part 2. Ah, wait. There we go. Oh, do I have to actually? Okay, let me do this. Wait, what? Part 1's here. Day 3's here. D03 P1. Like, what's going on here? D03 P1. Weird. So that's saved. This is saved. There we go. Maybe guess the file wasn't saved or something. So here is our map of each section, maybe? It looks a little off. It's looking a little off. Enum duplicate and then IO. Let's take a look at the section. Puts map section. What does our map section look like also? So that's what our map section looks like. Oh, interesting. Why did it? Oh, that's our results. Okay. It's formatting. I see. Oh, this looks okay. I think this looks okay. Okay. Now we do the traverse. Map X and Y. And then the solution was to, how many trees would you encounter? And I traverse, I'll have it return back a tuple or something like that with it containing the information. So let's do traverse. And traverse is going to take in the map, the X and the Y, do end, and then we do, so we have our map, and in our map, so we have our base case or our thing. So our data is going to have a trees 0 I guess that we only care about trees. So we only care about the trees. So the tree count. We can even do this. So this is fairly declarative. So tree count. And then so we go that. We give it the tree count, the map, and the XY. Now let's define traverse with the tree count, map, X, and Y. And then well, we can't do guard clauses here for this, I don't think, because we have to do like a check. Oh, yeah, we won't worry about doing guard clauses yet. So tree count. So now we want to check if the tree is there. So map. So first we get the row we're on, which is the Y. So enum at enum map at Y. So we get the row. And then we want to get the column in that row. Enum at X. And then if then we check if it's I don't even know what to call this. S for spot, or L for location. And L, if L is equal to, and our trees are the octothorpes. What if there's like a more like equality check in for string in here? Like a match or anything like that, or if we just do straight equality. Ba, 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 da, da. I guess we could do it contains. That's the way we do it to make it more. String contains, and then it would be the pound sign. This would be a case statement too. So we'll just assign this to a variable. I'm just trying to like think about fancy stuff, but as it contains is, if it is a tree, I think we do cases this way. Let's take a look. I have a thing open for this. Case and conditionals. Yeah, case something, and then I might be able to just do this. So enum tree count, that pipe to that, pipe to that, and then pipe to this case statement here. If that is possible. Can I pipe to a case statement? Let's test this out. IX. So 1 pipe to case X do when 1, and then the syntax is true when anything else false, and undefined function case. Okay. Yeah, so we can't do it that way. So I'll stick with the way original way I was gonna do this. So is tree do end. There's the end. There's our end statement right there. So if it is a tree, if it's true, we do tree count plus 1. If it's false, tree count. We just return back tree count, or anything else. is tree count. And then we traverse down again. Give it the map, give it X. I'm just thinking, because it's not X and Y. We start off at 0, 0. Yes. Sorry about that. My brother's just texting me if I can drop off the dog. If he can drop off the dog. I'm just realizing we need to pass in some original context of where of where we're starting off and stuff like that. So I'm gonna call this first method start traverse. Start traverse, we have our X and our Y, and then we actually do a traverse. And then what I'm going to do here is pass in a tuple with the X and Y coordinates in it. And the X step, which is X, and Y step, and Y underscore step, which is Y. Let's rename these anyway. That. And then we rename this X and Y. So I should make this happier, I think. Syntax error with X step. Really? Is it because I have to tell it that that's the... Syntax error for X step. Oh, yes, because we're doing tuples. We have to do the percentage. I think we have to do the percent symbols in front, if I'm not mistaken. So steps stays the same, map stays the same, tree count just got updated. And then now for our X and Y coordinates, now we update our X and Y coordinates such that it is X plus X step, Y plus y underscore step. Does that make sense? And this is just x and y. XX, YY. There, I think that does it. Okay. And then, so that will get us traversing through until I believe we hit an error. So I'm just going to go ahead and I outputs the current tree count. And this should break once we reach the boundary. As long as we don't ruin anything first. Numerals not empire for nil of atom type. This protocol implemented the following. So day 3, line 42. So enumerable is not implemented for nil of type atom. Well, one thing I noticed is like it's not upping the count. Let's see here. So we get our fancy map. And then we start to try to traverse it. We give it tree count. And let's see about this. I still haven't figured out I guess, oh wait, we can do debugs. I figured out how to do that last time, but let's just try doing manual debug by just doing this. So we'll check if it is a tree. So it's never a tree, apparently. I guess my assumption is if that would actually work. Strong assumption. Let's test this assumption out. Let's do a little test case here. My assumptions. So enum at I, and our index, our y index is 0. Pipe that over. Enum at, and that should give us the additional, right? And then we'll do enum at 2. What's that going to give us? That's going to give us that. string contains question mark that. That gives us true. Oh, looks like we lost connection to our container for a second, but still letting us edit, which is good. I'll just make it really to do anything. Reconnecting. Reconnecting. So either our map or our traversal is all wrong. Let's see about trying to do the debugger. So Elixir debugger. We have to do the include for the debugger at the top of the file, I believe. Let's see. Debugger Elixir. Here we go. And here we go. Pry. There was like a little example code, I think, where there we go. There we go. We can just do a single, a simple one-liner. Oh, looks like my brother's here, so I will be right back. So just give me a moment, folks. BRB. dog dropped off. Back to the code, back to attempting to debug the code. So let's see, if we're going to debug this, then we have to do mix. Was it the mix? What's the mix command? Ah, God, I can never remember it. Let's see. What is the mix command I always use to start up the terminal or to hook into the runtime for the application? Just pulling it up on my cheat sheet. And run a library. It's IEX-S mix. Okay. There we go. It's fine application IEX uses the current application, but the current application does not directly depend on IEX. To fix this, you must run the things if IEX is part of IEX dependency. Let's see if this works. Let's just see if this works. So if I run, what do you call it? Day. See if I could do this. Advent of code. Day 03 part 1. Oh wait, I need to run the actual mix task though. So it would be this thing right here, or so it would be under mix tasks D03 P1. Would this work? Dot run. Or is that not going to work because it's a mixed task? I guess that's the other question. Let's see. So D03 P1. Let's look this up because I've never done this before. Run mix task. Mix task. IX run mix task. Run stack. That was the only one that could have been potentially relevant. Oh. Let's see what happens if I just run it as mix then. And see if that just works. Mix. Is the IX shell running? Okay. So mix, and then advent of code. Oh, hey there, Juju. Let's try this again. Mix. Hi. The dog has come to greet me and run around below my feet. Here we go. So let's see. So run. So mix tasks. And then let's try to go to day. Can we go to day 3? Like what are our options here? What are our options here? Miss tasks. So D03, okay. P1, okay, and then there's run. And then just pass it something. A numeral not present of type. Here we go. Okay, we got it. So there you go. So I just had to get the right syntax because it required an args. So it looks like we hit the debug. So let's do a next in here. So eval next is not defined or primitive. So we hit the breakpoint. What are the commands we can do then? Help. Next. Uh-oh. Sorry, the dog jumped on the couch in the distance. Let's see, debugging. Debugger starts. Until continue is invoked. So let's try this. So I thought it didn't continue on. Continue. Okay, so it invoked that. Let's take a look at our map. So there's our map. No surprise there. Let's take a look at our x. Let's take a look at our x and our y. So what is our x? What is our y? That is 1 and that is 3. And then let's try running this through. So we do enum map and then do enum at x. So what's that gonna give us? That's gonna give us an empty. Why is that? So that gives us that. And then enum at x. So we're supposed to get this. And oh, what? I'm just noticing that there's empty strings in here. Why is that? I'm just noticing that now. How did empty strings get inside our thing? Maybe our parse row splits. So in our previous day's work, when we were parsing the rows, we split. Yeah, where did these empty strings come from? Interesting. Okay. Let's because we split up the new lines, convert these to graphemes. And enumerate that. And then we just count the width and the height. and duplicate each row. So that means that one thing is just our data's wrong. So let me take a look at, where did my binding pair go? There we go. So let's take a look at the map section. Wait, what the heck is going on here? What? What the hell happened with all the undos? Yeah, what where's the height calculation? There we go. That was weird. That was highly weird. So again, we have to do mix dot tasks dot day 03 part 1 run, and then just give it just some argument to use. Okay, let's see here. So so let's take a look at our map section. So our map section, for whatever reason, has empty strings in it. And don't know why. I guess when going through each row, we need to trim, maybe because, yeah, maybe there needs to be a trim that happens. So when we get the string trim, and then pass that onto that, and then that's what it will return. Okay. Continue. Okay. Let's try running that again and see what our map section returns now. Oh, it's the same thing. Okay, let's get out of here so it can actually load it in again. So tasks, mix tasks, D03 P1 run, give it an argument. Okay. Now we look at the map section again. That is looking much healthier. That is looking significantly healthier. Okay. Let's continue on. Oh, there we go. So we have the counts coming up and everything. So everything's looking good. And then we had a case where things crash because I think we reached the edge of the map. So how do we check if we reached the end of our traversal. So it would be if so we would return tree count if we reach the end. And we don't care about the step. We do care about the x and the y. So when x exceeds, so the first index is, the first thing that we go by is so when x or y, so the first thing to do is it is the rows on here. So if when enum, I'm not sure if this is going to work if we can access this because of the guard clauses. Let's look up Elixir. Let's look this up real quick. I think I have a better guide to this. Is Adam is binary when x is less than that, greater than that. So the comparisons we can do is arithmetic that animal n x joins is Adam is binary is number is record is that absolute. We get the length of a list. I don't know what a map, what is map size? So we can get length. What is map size? Map. What does that do? Map underscore size. Returns the size of the map. Okay. So we can do when y so the length of the list is less than or equal to y. I think that's how we can do it. X is unused, yes. Let's skip. Let's actually try running mix. Let's actually try running the task now. So mix day 3 part 1, and the result is 7. So we got the answer based off the input, and we quit once we reached all the way down. Now the question is it going to work with our input from part 1? So let's go ahead and try to do that. Save that. And let's see. And it looks like we hit a snag here. So it tried to do a contains for a nil. And then it broke. That's the gotcha. So we went too far in the X direction, I guess. Could we check for that condition in here? I'm not sure it's going to let us, but let's find out. Or length with enum. Or is it? I forget if it's list out or it's enum. Let me double check. Next meeting. Okay, we're good. Let's look up Elixir again. Oh, actually, we already wrote it out here, so I don't even need to do this. Enumat. What am I doing? Enumat with map or map y is greater than is less than or equal to x. So I'm not sure if it's going to allow us to do that guard clause. Yeah, invalid expression or is not allowed in a guard clause. And then it's pointing us to some nifty documentation. So we still don't know if we're allowed to do that. We can probably break that off into a separate guard clause then, if that's the case, huh? Huh. So let's just duplicate this. Get rid of this. Get rid of that. Get rid of that. We flip the usage of this. We care about X here. We don't care about Y here. And let's see if it actually we do care about Y. What's it? Cannot invoke remote function. Enum add 2 inside a guard clause. Okay, yeah. Do 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 do. Yeah, so maybe we can do so let's see here. A function We can try to do this as a case for functions. Where's that example here? So func, and then we do that when that. Okay. So we do func f, do that. If it's nil, when is, I think it's the guard clause is, what's all the guard clause conditions? Let's look that up again. Elixir guards, here we go. What was it again? Is integer is what we want, is integer. When x, or when not when x is an integer, when x is a list. Else we just return back false. Let's see if that works for us. It looks like the end online parameter does not have a matching do. Let's take a look at the example code here for this. It didn't look like it needed a do. Let's try switching it to a condition then. Condition do. If do this, then that. Maybe I just see can't do this. So let's do this is tree. So I'll switch this to a case since we have that is tree. It's still complaining about what's going on here? Oh wait, is it because of this? Will this do it? Let's check different conditions, the first one. And then here's our case statement. So let's switch this back to a case. Oh, it is already a case. What? What's going on here? There's obviously a missing end. We're so close. We're so close. We just need to solve this before the end of the stream. Why is this so beyond me right now? There is something missing in here. Oh my god, was that it? I guess I can refactor this. Oh, no. Thought I got rid of that error, but nope. This is not, it's an atom, I think, or a bit string. That's not going to pass anyway. I'm like desperate right now, so I'm not even realizing what I'm doing wrong here, because we are about to end stream, and I was hoping that we can get this out of the way. Yeah, so doing it this syntax didn't seem to. Little doggo is under me again. Let me try this. So if it's a false condition, do that. Otherwise, it should be a string. Yeah, there has to be a missing. Oh, is it here that we're missing it? No. There it is. There it was the whole time. When is bit string Wait, why is this complaint about is undefined or private? Do you mean contains? Yes, because we have to do that now. IX running shell, results are 0. Oof. See, now we just butchered our code, so now I don't even know. Now I don't even know what is right and what is wrong. Oh man. Let's see if we can go back to our previous case and see if that will give us our answer. No, that's not what we want to do. So that gives us 7. This is our new one. What if we just said repeat the graph like 1,000 times? $265 is the answer. So that might, so let's see, 265 is actually the answer. That's the right answer. Okay, so looks like my problem was that I didn't do the math to figure out how many times I needed to repeat the cells. So all I did was just repeat them a bunch of times and just see what happens. Not efficient at all, but that is what did it. So um, we just kept on recursively going through and passing in, going right three down one, right three down one, and recursively going through that until we reach the case where we can't go down anymore. Um, we're guaranteed to go right. I just need to fix my math for figuring out how many repeats do we need to do to going to the right and down one. I just screwed up that math because I wasn't trying to do that too well, because I knew I can just fall back to just making the repeat absurdly large. And we just kept on going down and double checking. So we check if these clauses here can probably be refactored to be more efficient, or at least more descriptive what's going on. But we just go down, check if it's a tree, and then if it's a tree we count, and then pass on that new count and keep on going, and we keep on accruing the count as we go down until we hit the bottom of the map and return that. And that's what was that. So luckily we managed to solve this at the very end of this stream. Definitely not the most efficient code. I am going to go ahead and try to clean this up. I'll take a couple passes at it. As with the refactorings, taking multiple passes at it is good. Just, take one piece at a time and try to simplify it. So first thing I'm trying to do is simplify this case statement and try to see if I can include it as part of the pipe. I might not even need this nil case anymore because we fixed the width of the graph. I think this issue with this nil case was a fact of we weren't repeating the graph enough times. So I might not even need to do this whole case statement here. So thanks for anyone that's watching or watching the VODs. So I hope you try admin and code 2 in whatever flavor of language you want, so you can learn like I am and trying out different things and trying and getting more used to a language you're not familiar with. The best way to do it is to do it by practice, and problem solving is the best way to do it. I think one of the best ways to do it, other than actually building an application. All right, everyone, take it easy, and I will catch you next time.